start belum? Dah. Alright, dah. Okay. Assalamualaikum, and today our group is going to present about the assignment, which is a pressure in pipe. We got 5 group members, which is Muhammad Fernanda Abdul Saiful, me, Aiman Ashri, Muhammad Harid, Ahmad Faidi, and Muhammad Anas. Okay, we're going to start with introduction first. I'm going to start with flow rate of water and velocity of water in pipe. Flow rate and velocity are related, but quite different physical quantities. To make the distinction clear, think about the flow rate of a river. The greater the velocity of the water, the greater the flow rate of the river. But flow rate also depends on the size of the river. As we can see, this equation seems logical enough. The relationship tells us that flow rate is directly proportional to both the magnitude and of the average velocity and the size of the river, pipe or other conduit. The larger the conduit, the greater the cross section of area. You can see here at the right, this formula that we use for this assignment. A is for cross section area, and V for average velocity. And down there also we use in the assignment, which is Q equal to V over dt, V over T, and the average speed is V equal to D over T. Okay, next.
Okay. Okay. I will I will explain about the Bernoulli equation. The Bernoulli equation states that from an ideal fluid, the sum of its kinetic potential and thermal energy must not change. This constraint gives rise to a predictable relationship between the velocity of the fluid, its pressure, and its elevation. Applying this equation to an example helps to make it clear. Consider a reservoir located up in the mountains with a pipe leading down to a town at a lower elevation. The pipe delivers water to a hydroelectric plant, and we want to know how fast the water will flow into the plant turbines. Okay, so we go to the Bernoulli equation. As you can see, these are the equation, and the below. So we can know V is the fluid velocity, P is the fluid velocity, Z is relative height, and the bigger P is pressure. Okay, next.
So the method of project. Can you slide to the picture, Aiman? Okay, thank you. First, we have to measure the water jet pressure and its velocity. Second, make a hole using a sharp weapon and put T connector to the pipe. And then the single connector we will use is distance of 20 cm. This the single connector. Number 4, the time taken were taken and repeat this step for each hole. Number five, the straight line pipe will record the data which each hole reach 20 ml to 100 ml of cup of water fill. And number 6, the pipe becomes straight line with the pipe have 5 holes with the distance of 20 cm each hole distance. And then the T connector were used to make the closed lock. The data were recorded of each hole when the water reached 200 ml of cup of water, and the time were taken of each hole.
Okay, the result is for the straight line pipe, number of hole each for each pipe is recorded. The time taken for to complete the cup 200 ml. For the each time taken 37, 38, 29, 39 and 60.13. For the loop pipe, if we can see, we make a 10 hole for each and distance about 20 mm. So the time taken is 16, 17, 18, 28, 60 and 17, 31, 23, 52 and 32.09. So this is the picture for the hole, for the straight line and the loop line pipe. So for the calculation, calculation, first we measure the maximum flow rate. We use the A over T. So we get the 7.14 centimeter cube per second. So the maximum flow rate is 7.14 times 10 power of -3 liter per second. So second we calculate the velocity. We use the formula V over A, V dot over A. So we get 35.51 meter per second. Third, the maximum achievable water jet. We get 68 centimeter. And we calculate the maximum pressure in pipe. We use the Bernoulli equation. We get 0.9342 atmosphere. So the discussion for this project is, we can see this graph is pressure versus area graph. We make a two-type pipe, which is a straight line pipe, and other one is a loop pipe. The pressure on the straight line pipe is smaller compared to the loop pipe. This is because the area becomes smaller and the pressure is high on the loop pressure. So the graph show the bigger the pressure, the smaller is area. So we can say on this experiment the loop pipe pressure is bigger than straight line pipe. For the velocity, it related to the pressure of the water. The higher the pressure, the lower the velocity based on the Bernoulli equation. The straight line pipe have a higher velocity compared to the loop because of the less pressure. So next conclusion.
Okay, I'm going to continue with the conclusion. In a nutshell, this experiment teach our group that difference make of pipe like straight and loop pipe have a different velocity and pressure. We also saw how to build ourselves the arrangement of the pipe setup before start the experiment. Many obstacles that happen during this experiment, such as our cloth become wet and hard to make hole in the pipe. This make us try harder and successful in the experiment. From the Bernoulli equation in the state that the higher the pressure, the lower the velocity. From this, we learn that the pipe velocity and pressure, it make the straight line pipe have smaller pressure but higher velocity, and the loop pipe have the higher pressure and but smaller velocity. Uh, Slide.
That's all for the conclusion.
That's all.
So thank you.
Thank you.
Well, we're in